question 5. Okay, so what we're actually doing here, so we've got the particle goes at height A, we're throwing it up in the air with an initial speed. It gets to a maximum point when the velocity is 0, then comes back down again, and obviously travels past A down to the ground. Now the key thing to realise is the speed with which we throw the particle up at A is the same speed as when the particle passes A on the way down. So there are more complicated ways of working this out, but the simplest way is just to realise that. So we just consider the journey downwards from A, and whatever our solution there is, we know that solution is the same as the initial speed as it was thrown up from A. So we're only going to consider the journey from here downwards. So we know the final velocity as it hits the ground is 28. We're trying to work out the initial velocity u. We know the acceleration is just gravity, is not 9.8, and we know the distance travelled is 17.5 meters. So having simplified this, we just substitute it into v squared equals u squared plus 2as, and that allows us to show that u is 21. Now for part B, now that we know u is 21, we just use another Sievert equation, s equals ut plus half at squared. We're now considering it being thrown upwards here, so u is 21, the acceleration is minus 9.8, because obviously gravity is acting against us. The distance travelled is 19, so substituting that into the equation, we get this quadratic. This can't be factorised, so we have to use the formula to solve, giving us t being 1.30 and 2.99. Now for part C, we start off with Newton's second law, F equaling ma. The forces involved as the particle impacts the ground are the weight of the particle, so 4, the mass is 4, so 4g, less the resistive force of 5,000. So the net force is 4g minus 5,000, and this equals the mass times the acceleration. This allows us to work out that the deceleration is actually minus 1240.20. Now we know as the particle hits the ground that its initial speed is 28. It carries on going until it stops embedded in the ground, so the final speed is going to be 0. We've just worked out the acceleration to be minus 1240.20, so substituting that back into v squared equals u squared plus 2as again, we can work out that the distance that it travels in the soft ground is 0.316 meters.